Hello, CP Finite Mathematics, and welcome to Lesson 6.5. Today's topic is dealing with how do you count the number of arrangements of a certain entity if order does not matter. Okay, we'll talk more specifically when those cases are for our word problems. But in general, today's word is a combination. So combination. Its notation is NCR, and it is an arrangement without regard to order. Okay, so for example, say you and 5 friends are going to Hershey Park, okay, and you're getting in the car, and it doesn't matter who drives, it doesn't matter who has what seat, it doesn't matter. As long as you're all in the car and you're all going to the park, you're happy, okay? No specific things from there. So all 5 of you are going. There's only one particular way you can all go, and that's if you're all arranged in the car. Okay, in general, NCR, if you want to use the calculator, it's in the same place. Math over 2PRB and 3 this time. So math, PRB, and 3. And it follows generally the same idea. If you have just an application like 12C4, you can just type that in and find your value. So 12 math PRB C4 is 495. Now, one thing to note, this is different than 12P4. So if order mattered and you wanted to try that one out, you're going to have a much smaller number for combinations than permutations. That's 11880. Okay? The reason is combinations gets rid of redundancies, gets rid of arrangements that are really the same. Okay? Common applications. So for letter arrangement, this is one type of combination. You're actually not going to use the NCR formula. Okay? You don't need to worry about that. How many ways can you arrange the letters in Missouri? Okay, the first thing is you want the total number of letters. Okay, so let's count up the total number of letters. MISSOURY. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 and factorial ways to arrange them. Okay, so 8 total letters. Factorial, we throw that up there. Now, you're going to divide by the repeat and factorial them. Okay, so the letters that repeat, I have I twice. So for the I's, I'm going to divide by 2 factorial. Okay, for the S's, I have 2 of those. Another 2 factorial for the S's. The rest of the letters don't repeat. Okay, so total over the repeating factorial letters. When you do this in the calculator, or you can also kind of think about it shorthand, I would just do 8 factorial divided by, make sure it's in parentheses, 2 factorial times 2 factorial. Okay, all that parentheses, especially around the denominator, and hit enter. So 10,080. Okay, 10,080 ways to arrange the letters. The reason that is let's say, okay, this blue S and this orange S, okay, are a little different. I could arrange this another way. I could arrange it blue S and then orange S and then the rest of the letters MIOURI. Or I could also arrange it orange S and blue S and then the rest of the letters MIOURI. Now, to the naked eye, these are really the same exact thing. They're the same. So it doesn't really matter the order that those S's are in, since they're both just S's. So that's why we're dividing by the redundancies. Okay, so Missouri, you can have fun with all certain different words now. Now, for ones that involve the NCR formula, those are going to be more specific, like how many ways can they be chosen. Most likely, if you see the word chosen, order doesn't matter. So 30 members in a class with their names in a hat. 5 names are chosen to leave class early. It doesn't matter what order they're picked. Okay, as long as their name's picked in that 5, they can leave early. So since order does not matter, we're using C. There are 30 total members. 5 are being picked. 30 C5. You can use the calculator, and you get 142,506. 142,506. Okay, that's really about it. 300 people in a selection pool for jury duty. I was supposed to go to jury duty, but I actually got out of it this past year. How many ways can a jury of 10 be chosen? So chosen, it doesn't matter what order they're picked in. They're all going to serve on the jury. 300 C10. Okay, 300 C10. 300 math C10. Oh, that's a big number, 1.398 times 10, that's what the E is, times 10 to the 18th. So notice they can still be large numbers, but just 10 out of 300 people, there's a huge number of ways they could be selected. 300 choosing 10. The most challenging, I like to think, for this particular lesson today are with card hands, and mainly because students don't know what's in a deck of cards. So 52 cards referred to before our deck of cards, or if you have one with you, you can kind of visualize what's going on. How many ways can a hand of 5 cards be chosen from a deck of cards? Really, when you have cards in your hand, it doesn't matter what arrangement they're in, so long as you have 5 cards. So that's why it's combinations. Okay, so 52, choose 5. We'll look that up. 52, I believe it's a pretty big number. Choose 5. 259 8960. 259 8960. I know my comma is off. 2,598,960 5-card hands. Okay, here are the challenging ones. How many ways can a hand of 2 queens, so 2 of the cards must be queens, and 3 of any other card be chosen? Okay, so let's think about how we can choose the queens. Again, order doesn't matter. So choosing queens, there are 4 queens in a deck, and I want 2. So for our queens, there are 4 of them, and I'm choosing 2. 4, choose 2 of the queens. And in mathematics means to multiply. So I'm going to multiply 4, choose 2, times, now 3 of any other card. How can I choose any other card? Well, there are 48 other cards. Okay, 4 of them are queens, 48 of them are not queens. And I want 3 of them. So this part's 48, choose 3. Now notice, these 2 queens and these 3, they equal my hand of 5. So 4, choose 2, times 48, choose 3 of the other cards. And I would highly recommend writing out these steps, okay? I'd be looking for those as for work. And once you do that, you can just type that whole thing into your calculator. 4 math, choose 2, times 48 math, choose 3. And you can do it in one thing, 103, 776. 103, 776. Okay, so it can be a little tricky, especially if you don't know what a card hand consists of. Okay, how many ways can a hand of 3 diamonds and 2 of any other suit be chosen? So let's just think. So for our diamonds, well, in a deck of cards there are 13 diamonds. I want to choose 3. So 13, choose 3. 2 of any other suit. Okay. Well, if there's 52 total cards minus 13, okay, that just means that of other suits, there are 39 other cards. Okay, so 39 other cards, I'm choosing 2 of them. All right, and means to multiply. So I just type both of those strings in, 13, choose 3 times 39, choose 2. 211926. 211926. Okay, and that is it there. So those are the examples for today. Especially 5 and 6, they can be trickier. So try those out. Try out the practice for sure. Write everything down. Another little side note. So that's really it. But if you want to know, so here's a little bonus tidbit of info. If you want to know what this looks like algebraically, our NCR formula is the number of things factorial all over r factorial and minus r factorial. So it's similar to permutations. That's the algebraic way. You can use your calculator. No big deal for that. Okay? Nice job, guys. Thanks for hanging in there. Challenge yourselves. Try out the practice.